and stuff like that. All right. Okay, so before we start proper, just wanted we will let one of our directors of engineering, Daniel, to first kick things off. Daniel, the floor is yours.
All right, thanks, Andrew. Hi, everyone. This is Daniel. I'm Director of Engineering for MoneyLion. I'm really honored and excited to bring you the first session of MoneyLion Tech Talk. For many of us, it's been more than a year since we started working from home. I remember the time before COVID hit us. There used to be so many tech talks, user groups, meetup, workshop that happens almost on a monthly basis. But since MCO started, the number of events has just dropped significantly. And because of that, MoneyLion, as one of the leading tech companies in Malaysia and in KL, we want to play our part to revive the tech community. So we initiated this tech talk for a few important objectives in mind. First, we want to increase the knowledge sharing among the tech community in KL. Second, we want to allow the technical people like yourself to have the opportunity to network with fellow developers and engineers to really form the support network for each other locally. Third is to provide a platform for some of the talented technical people to present and to share interesting experience and knowledge that you have. So if you have any topics that you would like to share using our platform, please feel free to reach out to me, drop me an email. I'll be happy to chat with you. So in this first session, we have lined up 3 very interesting topics: JAMStack, Odata, and Event-Driven Architecture. So JAMStack is a front-end architecture that got more popularity in the last few years to make your front end really blazing fast. We are going to have Ivan to share with us in a moment about that. On Odata is the second topic, where it defines the best practices and guidelines for developing RESTful APIs. Hossein is going to tell us more about Odata. And last but not least, Jing Yong, one of our tech leads in MoneyLion. He is going to share with you more about event-driven architecture. So the speakers are some of the most talented developers and engineers that I have worked with in the past. I'm sure you will be able to learn something from them. So without further ado, I'm going to pass it over to Andrew to introduce the speakers to you. Enjoy the tech talk.
All right, thank you, Daniel. Okay, so before we also proceed, before I introduce the first speaker, I'm just going to answer a question which will inevitably pop up. Will the slides be shared? So the answer is yes. After the event, we will compile the slides from the speakers and then we will send it to you guys. All right. Okay. So without further ado, so let's proceed to the first speaker, Ivan Brygar, senior developer of Sitecore, will give his talk on JAMStack. JAMStack as the revolution in the web world. What benefits does it bring and why should you know about it? So Ivan, the floor is yours.
Thank you, Andrew. Hi, everyone. Let me share the screen. It's loading. I believe you can see it already.
Yep, yes, we can.
Yes.
Nice. So let's talk about JAMStack right now. If you don't know what is it JAMStack and you haven't experienced with it, I will try to explain my best to you about this technology. And what is it actually JAMStack? Which benefits does it bring? Then we will talk about how works Sitecore versus Sitecore with JAMStack. We will talk about CDN, how it's important nowadays. Then we will talk about the static site generator, and I will show you the demo. And I believe that after the presentation, if you even don't know about JAMStack anything, you will understand the whole concept. You will be able even to start your own JAMStack application. So what is it, JAMStack? Actually, it's a relatively new architecture for web. And in other words, it's approach to deliver website. For the longest time, we have used the traditional server-side or rather server-dependent architecture. For example, we have our browser and we have to request any resource, let's say some page from the web server, and then web server requests some data from database. Then data back to web server, and web server send back to browser, and it's render the website. But now the Jamstack allows us to create incredibly fast and reliable websites without any of complicated and fragile server-side dependencies. Yeah, even if web server has the really brilliant code, it doesn't mean that it's stable, because we can face some other issues with scalability, etc. So what is it, Gem? How can you imagine it? Something like this or something like this? And to give your visualization, to remember what is it, you can think about the gem that it's JavaScript, API, and markup. And stack is just a layer of technology which deliver your website or application. And I can show you the analogy. For example, a lamp, it was quite popular before, and it was Linux, Apache, MySQL, and PHP. So it's another stack. But let's talk about the Jamstack. As you can see, we have three different layers. And for JavaScript, you can use React or Angular or Vue.js, and it doesn't matter which library or framework you will use together with, for example, Elasticsearch or your custom API. And for markup, we have different kind of static site generators. The most popular are Gatsby, Hugo, and Next.js. And actually, you can mix everything between each other. For example, you can use React and Elastic and Next.js, or Angular, your custom API, and Gatsby. This is just for your experience. What do you know best? Now I will tell you about the benefits. Please remember the main benefits right now, and after I will explain each point that you will understand it on example. The first one is speed. Jamstack provides incredibly good speed because our site is static generated, which serves really quickly. And it has great cache validation. I can show it during the demo. Then security. Security is extremely great because nothing to break. Our CDN provides the static assets. Then scalability. Another benefit, huge benefit is scalability. It's very easy to scale on CDNs. And development, easy to develop because we already have many solutions for developers, and there are different frameworks which are ready to use. So remember these important benefits like 3S: speed, security, and scalability, and development. And then I will explain you what actually does it mean on flowchart example. The next slide is kind of complex, but don't worry, I will explain everything and you will understand everything from this slide. Let's say we have Sitecore instance. Yeah, I work at Sitecore and will show example on Sitecore, but actually it doesn't matter which one to compare. And Sitecore, simply saying, it's a kind of content management system, but it's actually much more complex thing. And at the top, we can see the first use case where we have client which use the native Sitecore instance, but it can be like Adobe or WordPress or anything else. It doesn't matter. And another example, we have client with Jamstack experience. And now we will see and know the difference and which benefits Jamstack actually brings. So let's imagine that we, in the same time, send request from the clients to one web instance, which is Sitecore, and another with Jamstack experience. So let's send our request in the same time. It's arrived equally the same, and then the interesting things and difference happens. Our CDN on Jamstack already has all the necessary assets. It's HTML, JS, or CSS files. But for some systems like Sitecore or something another, which has a lot of background logic, which rich with different features, we have to retrieve our data. And at the time when, on the second example, our CDN already going to return the files back, on the first example, backend execution is running. It's go through all of the ASP.NET lifecycle, some pipeline jobs. In the same time, it execute some processors. Each processor can get some data from indexes or from database. And as you can see, let's just run it again. Request executed. This one already done, but any another system will run the heavy logic under the hood, and eventually it will, of course, return the needed data. But the thing is that CDN already have all of the cached assets. And difference between common approach and with Jamstack, around Jamstack increase speed like in 10 times to the first byte. So now we can see that it's increased the speed because we just get in the static files. Then it's secure because we don't perform any backend logic with Jamstack. We just retrieve the assets, already generated files. And scalability, because we can easily to scale our CDNs, we can add load balancer, and we can add one or more additional CDNs. And each time client with Jamstack experience will take the needed assets really, really fast. And now you now you may ask what actually happens here at the gray area, because there is something like get data via JSS during application build. I will show you on the next slide. So I started from the higher level, and now we will go deeper to understand what actually happens and how to make our Jamstack application available to run. So this is the gray square, what I just mentioned to you, where we have our CDN. For example, it's Netlify. I will show you what is it. I will explain the benefits, which already has all the necessary assets: HTML, JavaScript, CSS files, and maybe some images. And in the same time, we have the Sitecore instance. And once again, it can be a WordPress or anything else, any another system. And what happens between them? First of all, Sitecore support GSS. This is Sitecore JavaScript SDK, which we can just install on top of Sitecore instance, and it make our instance headless. And I believe that any another system has some similar functionality, but the main point, we have to provide some content via API. What happens next? We have to create our SSG, which is static site generator. which will fetch Sitecore content. Then our content, our source files, source code will be stored actually in Git. And it's really great and fast workflow for developers, because if we create the static site generator, we are easily can push one or another change to GitHub, just the source code. And then we have to connect our CDN, for example, Netlify, to GitHub, and it will looking for the change on our repository. So Netlify will just consume the source code from GitHub and build the application. Then it will publish the application, build and run and publish the application to the CDN. But actually, our content at Sitecore, and it will be already on CDN during the build. So actual content fetch happens during the application build. When our clients will request some website from our CDN, from our Jamstack approach, all the necessary data are already stored here. It can be a list of users or some articles, etc., etc. So our instance shouldn't go through the logic, shouldn't go to the database or indexes, because all the necessary changes are already under the CDN. The next is, let's talk about this static site generator. How to make it? This is actually the main point of Jamstack approach, that we have to create static site generator somehow. And actually, on the market, we have a lot of open source generators, for example, Next.js, Hugo, or Gatsby, and actually it has a really long list. It's maybe hundreds already. But this is the main popular generators. Each generator has more or less the same possibilities how to handle the application. And let's consider that we choose the Next.js, and it has one of the main properties, get static props, which actually generate the static assets. And the code looks pretty simple. We have to write asynchronous function, which will have the name get static props. And then we will fetch some content from the API, and then just serialize it to JSON. We have the data property, and this function will return these properties, this content already to the page. All the necessary documentation actually on this website. It has kind of gamification structure where you can go through each step and execute one piece code after another, and eventually you will get the application. Let's back here, and now I'm going to show you a simple demo how can we use Next.js and Netlify. So our Netlify, this is a CDN. So as it said, it provides really fast CDNs, and it's really a modern service, which I really recommend you to try to use in your projects, where you have just simply to register. I already registered. I have to log in. And then we will see some admin panel. But now it's not really interesting, because for creating some Jamstack application, we need to consume some data, some RestApi. And this website, JSON placeholder, has a list of different APIs. For example, posts, we can consume it in our application. Or as you can see, some comments, photos, another entities, or users. I propose you to use this content for our Jumpstack application. And the next useful site is Jumpstack Org Generators. And as you can see, it has a kind of predefined templates for different frameworks, Next.js, Hugo, Gatsby, and many others. If I scroll down, yeah, it's kind of infinity resources of generators. But let's say we are going to utilize the Next.js. And each of the frameworks has a button deploy to Netlify. And it's really easy to deploy our project to Netlify, to connect it to GitHub, and it's easy to make with a few clicks only. So I click deploy to Netlify. Now it's loading, and as you can see, it's already preparing some pre-generated data. Now it's asking connect to GitHub. I'm authorized to GitHub and have just to type the name, repository name. Let's say it's TechTalk demo. Then I should click just save and deploy. It takes just a bit of time to perform it. And as you can see, we already have the status that it's building just after a few clicks. And if I go to my connected GitHub and refresh the page with repositories, it's refreshing. Yeah, it's already here. We have new repository, TechTalk demo, and it has all necessary actually code. And let's back to Netlify. It's building. It takes around, we even can click and see the logs. It takes like 30 seconds to 1 minute because our application is still empty. It doesn't fetch any data yet. So in the same time, I can go to my new created repository by Netlify with Next.js template and can copy the code. Let me just get it to my local machine. It's easy to clone, pretty fast. Okay, I'm already on the last revision of released Next.js. And let me open this template. Open folder, should be somewhere under the documents, TechTalk demo, select. So this is our simple Next.js Jumpstack application, which has some folders, and the main file, which is entry file. We can use one or another code. I have prepared some snippet. It's not really different from the beginning, but what do we have here? We can see that I copied this URL users, and I'm going to fetch this data, fetch this content. Then I will return this property data to my page, and as you can see, I use the getStaticProps. It's just notation of the Next.js generator. And then I return the property entities in the workers. Then I map each of the property and actually can build it already. Let me npm install. Actually, under the hood, it use React. Let's give some time, around 1 minute, and in the same time we can back to our Netlify. I believe it's already done. Yes, site is alive. As you can see, we haven't coded anything except that I put some snippet on the main page. And yes, under the Netlify, it generated some random name, but I can also make it to rename tech talk demo. Saved. And this is our URL for our Jamstack application. And currently, it just a template. It doesn't fetch any data yet. Our application locally has been built, and if we run it locally, we will see exactly the same result, because Netlify also use the npm run dev or some similar command, which run and publish it on the live site. So locally it's ready. And if I open localhost with port 3000, we should see exactly, we already see the fetched content. Because I render it here where I use worker name and our APIs is like, what does it have? ID, name, username, email, address, and some internal properties. Let's say I'm going to add something additional in our application. I will copy this string and put some extra. Let's say, what do we have? Name can render email, just another property, email, and let's say address and city. So I have to type address, everything small, city, and I've saved, just pressed Ctrl S, and it's actually compiling on the kind of on runtime on the flight. And if I go back to my application, which is local, there is typo to S. Save again. And we already have all the necessary data on our website. And of course, you later on can add some styles, make it pretty, but the main thing that we already have our data content during the application build. And if I go to my source tree, you can see there are some differences where we fetch the data and get some properties and render them to the page. And I go and just publish to commit and push this change to our Git. And it looks like really simple. Edit, fetch data, and I'm going to commit it. And the next magic happens with Netlify. So I just commit one file, but what actually happening now? Our Netlify service, as you can see how it looks before, if I go back here. Let me refresh the page to open the current project, current solution, Tech Talk demo. As you can see, we just publish some change, but it's automatically started to build our solution. No need anything to add like from manual work. Yeah, it's already published. Then I'm going to go back to our live website and just press refresh the page. Yeah, on the live website, we already have all the necessary content. And if I open the source code of this page, let's see something from our API. Let's say Clementine. Let's copy this name and the proof that our content already in asset. I will just search it. And as you can see, our API, our JSON already under this page. So when clients trying to open our website with Jamstack approach, we don't go anything to web server. We don't utilize database to fetch the data. We already have the data during the application build. And yeah, for every another new change of our application, let's say we have added some styles or we have added some additional property to render, we just push the change, and in 30 seconds, our change is already on live. And it's fast and easy. The next, what I would like to show you. So previously, where is it? Yeah, previously I showed you the resource about Jumpstack generators, where we can just grab some framework and start working immediately. There are many options what to choose. And one more resource, which is also fruitful and rich for different templates, is Jamstack teams.dev. As you can see, you can choose one or another SSG. You can use even some CMS. Yeah, some of the CMS already support out of the box the Jamstack. Also, you can filter by CSS what you would like to use. And then it also, we can create a website with few clicks. Let's say new Next.js. We have 20 themes and create website. Now we will see how it looks like. We still can change our repository or some another theme. We can rename and click create website. So it's promising that it will take less than 60 seconds. Currently, it's preparing new solution with static site generator, and in a few seconds, we able to use it and again publish to our GitHub, then take the source code and evolve our application as we need. Let's check for the next seconds. So with these two resources, what I just shown you, you already can start the experiments. Which one approach would you like to try? So it even doesn't require some programming skills at the beginning, but then of course you have to write some code to fetch some data. And this example even provides some CMS system where we can modify our content on the flight. It's like SaaS. And then this configuration publish to our request transition to our GitHub, and then we can use this template. Pretty easy. And yeah, there are useful links what you can learn. It's Netlify itself, Jamstack Org Generators, Jamstack Teams, what you can use without any difficulties, and some documentation, some interesting documentation about the Next.js, how to fetch the data. So the main thing of the Jamstack application, just fetch somehow the data from some API, from some REST API, and utilize it in your application. That's all. And yeah, that's it from me. I believe you have learned something new. Thank you.
All right. Thank you, Ivan, for a very insightful session. Like I just wanted to reiterate for some of you who just came in, don't worry. If you have any questions for the speakers, we will have breakout rooms later, so you can just approach the speakers later and just ask them any inquiries about their topics of interest. Okay. So next up is our second speaker, Hossein Amri, CTO of Axceligent. His topic is OData, a better solution for the REST API war. So his talk is Discover OData and how to build and consume a RESTful API that adheres to OData using the ASP.NET Core and EF Core. So Hossein, the floor is yours.
Okay, thank you very much. Okay, let me share my screen so we can start. Okay, I believe that I am sharing my screen. Can you see?
Yes, you can see your screen.
Okay, cool. Cool. Okay, so I think everyone here should know a little about REST API. I just cover what is there, and then maybe we can think about what is not there. So, so the REST API, so everyone of us knows that it's starts with some HTTP or HTTPS, then a domain name, and there is some other part after that. So usually the REST API look like this. And for example, we make it more clear that, for example, this this is an API, so we just put a prefix of /API. Or for example, if we have a versioning, we just put the versioning there also. So, but the actual question is, what is this some URL things? So, so this some URL thing, what's that? So usually the best practice usually is to put the resources there. So if we agree that, for example, we want to put the resources there, or if we then, for example, if I want to give you an example of, for example, let's say you have a database of the family and family trees, then, for example, it's going to look like this: is you going to put, for example, a resource in there. And for example, if you want to access one of these family, for example, database of family, you just put a slash, and then you tell what is the ID of that, for example, family. For example, you want to access family 1, so you say family /1. So until here, everything is good. But because you also want to show that there are so many families in my database, you are just accessing one. So instead of you put family, you put a plural of family, you put families. So your REST API looks better. So you already tell anyone that is your potential API user is going to know that, okay, you have a bunch of families in your database, and you are, for example, you can access to one of them. And for example, if I remove /ID, it return you back all the families that is available, for example, in my database. Then let's say, for example, you want to let the user to to dig in more into your resources. For example, let's say under each family, you have, for example, a list of the siblings that each family has. So probably you put a /siblings in front of that. So it show you that you have one resource that was families, then you access one of them, then you dig in to rest of the information that is available there. So then, for example, another possible resource is, for example, brothers, or you can arrange the resources that is available there in any way that you like to. Then, for example, if you want to access to one of those brothers, then probably you do the same thing that you did as before. You just put the /ID there to access one of those brothers. But you just need to know what is the ID of one of those brother or siblings. Then, for example, if you don't want to do a versioning, that you just remove that /version, and then you are going to have a shorter version. So until here is just a happy pass. Everyone is happy and doing good things. Then, for example, if I assume that, for example, you have this URL, then probably you be able to communicate with it with the different HTTP verb. So I think everyone is knowing about the GET. So this one is giving you information about one of these, for example, family. Then if you like to get all the families, then you just remove, for example, /ID and you get all families. Then, for example, if you want to add one family to the list of the families, you do a post. Then there is a patch. So if, for example, you want to edit a part of the one of the families, you don't want to override the whole thing. You just want to patch it. You want to partially. So if you want to remember the patch, usually I see in the technical interviews, they say what is the difference between patch and put. So patch you can relate it to the partial. So partial override, you can do it patch, and you can put. So when you do put, you are overriding the whole things. And supposed to work like that. If your API, for example, you are not doing this, probably this things is considered as a best practice. So post to create, patch to partially update, put to the whole things update. Then you can do a delete, and you delete the whatever resource that you are, for example, here you are talking about. So this is all best practices. This is the rest. Good, everything looks fine, and you are doing that. You think that okay, you already nailed the REST API. Then it comes the ugly part of the REST. So the ugly part of REST is, for example, until now you was doing, for example, I create a REST API that is giving me the families. Then after that, your application is evolving, new requirement is coming to you, and for example, they ask you, give me families with the one child. So what option you have? You are creating your REST API that give you a list of the all families. Then you have two options. You let the user to get the list of all the families, then go through one by one. Or for example, you can okay, here I did a mistake. I shouldn't put this ID here. So then requirement tell give me families with one child. So this is quite going to become quite troublesome. You let the user to fetch everything. After that, filter it, or for example, do it on your front end. That is probably Angular, Vue, or whatever that you are using. Then it's going to be costly. It's costly and not efficient. Why costly? Because, for example, if you are using something like a Cosmos DB, they charge you based on the number of the reads. Or for example, if you are going to spend your bandwidth, or you are going to give a lot of information that is already not needed. So you need, and you want performance. So for example, let's say you have millions of families in your database. You want that query somehow happen at the database side. So it doesn't make sense that you expose for such things, you go and fetch every families and do it on the front end. You need the backend provide the data. So you start to put, for example, you create a new API. It's with one child. So is it become families? Okay, this just imagine that, for example, this shouldn't be exist because it's my mistake. So you are saying families / with one child. So if such things happen, then, for example, another day, another requirement comes and say, for example, give me child without a child. And so you're going to go and create another endpoint. It's like you are putting things there. And again, it is my mistake here, so I apologize. So here shouldn't be, these things shouldn't be here. So another day, another request comes and say, give me married people that is married last month. I want to create a report. I want to put it into the one of the widgets that in the, for example, in your page, give me the people that married just last month. So is it like you are starting doing things that you shouldn't do? We discussed that, okay, we are going to put the resources here, but now your business logic are in your URL and the controller. So if you see, this is a business logic. Actually, give me people with the one child, give me with the people without the one child, because one part of the application is going to use this, for example, this result, and another one going to use another one. So you're starting to put your business logic in the controller, and you don't see it, but it is actually in your URL. And after that, you are going to, for example, you're going to do an action on your resources. For example, you have a families, and again, this is my mistake. I shouldn't have this ID. I can have this ID here. So actually, this is correct. Then you want, for example, you want to tell them, okay, make them divorce. So you say, okay, I want to make them divorce. But then you need to think, when I am doing a make them divorce, am I doing the should I use put, post, or patch? So this is an action. We are agree that, but we have a put to override the whole things. Then we have patch that we need to, we're going to use it if we want to partially update something. So probably this one should be patch. Or we have, for example, post, that the post is to creation. But we are here, we are creating a new divorce item, for example. So it's like, should I use post or put or patch? So this is become a question. And again, this is another portion of your business logic that is already here. Then, for example, you have, for example, you're going to end up with a different rules and different implementation. Each developer is going to start to do their own things. For example, another developer say, okay, mark this, for example, this family as a retired. Then what do you do? For example, another developer probably use patch. Or another developer, for example, you want to say that, for example, this family married to another family. So the first thing is you need to know the ID of two families. Then, for example, this married to is actually a verb. It's like you're not talking about the resource anymore. You are talking about the verb, and here you are talking about you are going to use post. So you end up to mess around your REST API, and we agree that the resource should be in the URL. So here we was talking about the families, but at the end, for example, or we previously was saying families /ID /siblings. Then at the end part, we start to talk about the things that we can do, or the business logic that's applied to those entities. So it's become a little like we didn't agree on that. We was thinking that these entities should be in the URL. Well, what happened to those action that we applied on the URL? So usually the REST API look like this, and we already discussed about that. So you try to become more clever. You are saying, okay, I'm not going to put those business logic in the URL. So I'm going to do other things. I'm going to accept those things as a query parameters. So you're saying that, okay, if I want people that is, for example, is divorced, I'm going to introduce a query parameter of the, for example, marital status. And I say, okay, give me people that are divorced. Or for example, give me people that age bigger than or age less than. So it's like you're going to create different query parameters that is representing your business logic. So this is can be done. There is nothing wrong to do that, but you're going to just move your business logic from the part being part of URL you are putting into the query parameters. So if you're doing it part of the query parameters, it's become a little harder to discover, but still it is much better than if you put it part of the URL. And for example, there are some stuff is there that you cannot avoid it. For example, one of them is count. For example, if you want to get the count of, for example, the families, again, it is my mistake, I apologize. This thing shouldn't be here. So for example, if you want to get the list of count of the families, what do? You cannot put, for example, give me a dollar count equal to true. So then, for example, it's not a bad things to do that, but again, we can avoid these things with other way. So this was the problem. So I am Mohammad Hossein Amri, I'm CTO in the Axceligent, and this is my talk why you should consider to use other solution than the normal REST. So I am at the moment I am an Axceligent. So I want to tell you why we come up to this conclusion that Odata is a better solution for us. So in Axceligent, our flagship product is we call it RoboEdge. So it is a product to digitalize and automate end-to-end business process. So we let the people to do the digitalization and process improvement. So through that, we are facing a lot of companies that our application should be dynamic enough to be able to cope with all those new requirements. So we cannot go and create our business logic into our URL, or for example, we have a fixed set of the URL. All these companies is going to use our application in many different ways, and each of them has their, just believe me, each of these companies has their own set of requirements. So the main pain point of any software, I think, is going to be like this. So your application need to talk with the analytics. They want to get reports, they want to do things. So there's like, you want to open the door of your application to the other application to come and collect and to get the data, fetch the data, work with the data. But to be able to do that, you're going to have a very hard way of achieving it. So here is enter Odata. So I want to tell you how to use the Odata first. So actually Odata is is deep as an ocean. So it's like the thing that I am talking today is just fetching the data and work with the data. How you provide the data, that's totally another kind of story. So the Odata is a standard to how to provide and how to consume a data. And Odata isn't Microsoft only, is created by Microsoft, but it is open specification, and Microsoft guaranteed long-term availability for the others. So it's like Odata is not only limited to Microsoft, so you can implement it anywhere that you like. So later I will compare it with GraphQL, but just in the mind that Odata is somehow work like GraphQL. So this was the URL that we was discussing. So probably this is until here is a normal REST API. So the first thing that the Odata is enforce you, for example, you can still go and put a back a slash like this, but the first thing that Odata do is telling you, okay, for example, you put a parenthesis to when it's something related to each other. So this is a little more cooler because it looks like you are working a function. So it has a little nice touch to it, and also you know that what is related to what. But compared to this one that you are, for example, you are just having a convention that these two related to each other, That one is more like a function type. Then after that, these things can be anything. For example, it can be, for example, a name, or for example, I give you an example here. For example, I have the URL, whatever that is a part. Then you have whatever the resource that you had, for example, families. Then you pass some input. So for example, here we have the people as a resource, and after that we have some input that is a text. Then when you have the information, the result that is you are returning, you can do a select. You can select some of the field that is available there. And it is cool because, for example, if you just need 1 or 2 field there, you don't need to fetch everything. So this is work quite fine. You can do it on the single entity, or you can do it on multiple entity, and it is working just fine. So you like, I have a list of families. I can fetch the information, and I can select some fields, and that selection apply to every of those, for example, families that I have. Or for example, if I have 1, it's going to apply to only 1, and for example, you can get 1. So the magic is use $select. So this $select is going to apply there. Then if you want to get, for example, top 2 of the things, so you just say $top equal to 2, and it's going to be 2. So this $top, $select, or whatever things that I am going to talk about is all part of the open specification of the OData. Then, for example, if you want to skip some of the results, so for example, let's say I have 10 results, I want to skip 2 of the first 2, then I can do such thing. And if you mix and match these things, you're welcome. You already have pagination. So I think it is already worthy that you have a pagination on every single REST API endpoint that you have. It's like you don't need to implement anything extra. It is out of the box. You have it. So then, for example, if you want to do multiple selection, it is going to be a comma separated. So for example, you say first name, last name, and for example, you just select 2 fields on top of this. And then if, for example, you want to merge it with the other part, you just put the and, like normal REST, normal API query params. So this is your first parameter, this is second parameter. So the separation of the parameter usually with the and. So this is very easy. Then if you want to do a filter on top of any of the available fields there, you can do that. You just need to use $filter, and after that you say the name of the field, and after that you have a list of the, for example, if you want to, you have a greater than, you have the equal, you have the, for example, not equal. So if you work with the PowerShell, probably you saw these things. Or for example, I think I believe in Python have I'm pretty sure, but I think Python has the same thing. Then you have, for example, greater than, not equal, for example, greater than, greater, equal, less than, less equal. And you can, for example, do a contain any or all. For example, if I go with another example, so I have $filter. The parents is the entity for the results that is families returning. So let's say for a families return, one of the field that is returned is parents. So I am saying inside the parents, search for any that is married greater than, that is married more than 60 years, for example. So if I want to translate this one, if you see in .NET Lambda, for example, it is just an anonymous function. So you are in your URL, actually you are writing anonymous function. You are saying in my, for example, in this result return value, search for anything that is married is greater than 60. How much cooler than things you want. Then, for example, you want to do a search, and when you do that, for example, you say $filter, and you say, for example, contains. When you say contains is searching, it is like a you're doing the substring search. So for example, index of, and you're saying, for example, it contains a parent /name. So when you say parent //name, so you should understand families return a set of results that result has, for example, has the parent. That parent is, for example, a JSON, and that JSON has a field of name, and on that child parent child field, I'm going to search for anything that contains value of Amri. So it's like, if you want to do something like this, so it's like I am writing my query on top of my URL. And for example, if I want to make it harder, I can do and then I have another set of filter value. And the good thing about it, I don't think I have enough time to show you, all of these things can be converted to the SQL equivalent. So when you run a profiler on your SQL, you can see that you have for example, SQL that is going to be like percentage. Then on this field, for example, it's going to join two tables, and on this field is going to like percentage, Amri percentage, and for example, it's going to on top of some other fields that is, for example, married is greater than 60. Then you can instead of and, you use or you can use not. So it is up to you how you manage your logic, but you can do more stuff. One of the good things that you can do, you can order by any fields on any level. So I am saying that order by birthday in a descending. I remove descending, it becomes just ascending. It's just very easy as that. And one more thing that I want to say is, you can go into the different level by /forward. So if you in the Odata, the way that you to go to the different level of the item is the /forward. Then before I move forward, I need to talk about the metadata. So in Odata, there is a discovery path that is $metadata. So in any Odata, you should have these things. And if you use ASP.NET version, it is out of the box is there. So when you open this $metadata, is going to show you XML. Unfortunately, the Odata is very old, so they used XML, and it still is part of the standard. So when you read these things, you will understand that there are a couple of entities there. So there is entity and navigation property and complex and enum. So you should understand that entity is anything with the ID. So for example, as long as you have a primary key, it is an entity. So if you don't have a primary key, then it's going to be considered as a complex. And if, for example, you have another entity that has related to another entity, so it is considered as a navigation property. And you have enum. Enum is just a list of the value that you have. So when you understand that you have navigation entities, so you can expand them. So when you expand them, by default, Odata give you one level of the result. Okay, give you one level of result. If you expand, you can go as many levels that you like, as long as some data is related to each other and has a navigation property. Probably if you are using EF core, probably you have the navigation property. If you have a navigation property, you can expand it. So there are some security concerns, because each time that you expand, you are doing a left join in a URL. So to avoid people to misuse it or abuse it, you can limit how many levels the person can expand. So I think 8 should be good enough. So you can limit how many times you can expand, but you are doing the left join actually on the database level. So you just tell what is the navigation entity, and you can go as many levels that you like. So for example, one of the examples that I can give you is, like, for example, I have families, and these families I have, for example, I expand the parent. And if I do expand the parent, then, for example, I can do a filter on top of this parent. So it's just you open the parentheses, and again, $filter, this is whatever that we had it before. You can have it inside for this child entity. So it is just like you already do a join. You just, if you in the SQL level, you can imagine that you did a join. on the join level, you are doing a filter on that level. So it's pretty cool. Then you can have another filter at outside. So if I have another filter outside, actually this filter apply into the families, and this filter that I have inside the parentheses apply to the parents. And on top of that, I can do a select. So it's like you can mix things together to get whatever result that is desirable for you. For example, here in here I did a filter that at this level, and then after that I can do another filter that is at the top. Because I told you that the forward slash is the way that you can chain the levels. So at the outside I could do this, or I could do at the inside such thing. So it is both doable. Then one of the things that is very pretty cool that you can do aggregation. For example, there is a $apply. After that $apply is get some function. One of the function that is get is aggregate. You say, okay, I want $count and I want to return it as a total count. Then it show you it return you total count and just put the value of $count in that. So this one is, you can do a lot. Families has a child field, then it is going to be then you tell that I want to get a sum, and after that I want to name it as a total child. Or you can do a couple of things. For example, I want to do for example, get the sum of the child, and I want to get the age, the average of the age, and I call it age average. So you can do as much as you want to. You can do it all only on top of the URL. So it's like the user can do anything that they want. Then if you like to group by at that point, is like you can do also group by. So you say $apply first, that was before. Then you say I want to group by first. I want to group by for example family slash I don't know, race, country, or whatever, so, or ID. So family slash ID actually was a very bad example, like if it doesn't make sense. But anyway, so family slash, for example, let's say country. Then after that, I want to aggregate and I want to get the sum of per, for example, country. I want to get average age per country. So it's like your database is inside your URL. Then, okay, I passed the demo because I am already 30 seconds over my time slot. I go to the pros of the OData. So a standard communication, no need guesswork. You have the full control of your your business logic at the front level. But it is a little hard to follow every aspect of the standard. I didn't touch a lot of the edge points in this slides, but there are a lot of edge points there. Then, but if you like to just enable this query things, it is just you can opt into the query things that I show you. It's not like maybe you don't want to implement the whole things. It is up to you. You can do that. Then it is the good thing is you can get out of the box integration with other apps. The good things, because it is standard, and every other application, just big application that is out there, Power BI, Tableau, SAP, any application that you name it that is the enterprise level, they support it, and they can just hook into your data and just read your data. It's like you just open the door to any other big application to come and collect it, to get the data. And the awesome part about this, in .NET, it created link queries, and that converts directly to SQL queries. So it's like you just need ORM that understand the SQL link queries, and it is one-to-one. In Java also it's doing that. I'm not sure about the other platform, but I know that because the .NET and the Java has a good ORMs, that thing is getting done, and it is quite awesome. But there are some cons also. So the problem is you are exposing your whole entities So you are exposing the database entities, and also there are security risks. For example, one of them that I mentioned is how many level you can get down into the do a, for example, left join or right join on the entities from the URL level. So you are exposing your URL, your database for someone to, they can do a lot of left join, or they come up with the very wrong queries to just bring down your server. So there are security concerns. Those security concerns you need to apply. This is just, there are some settings you need to make sure that you apply, you set it up correctly. Then if you don't want to expose your whole entity, there are libraries like Automapper. Automapper already have extension for the OData to handle the, for example, you don't want to expose, for example, a password, or for example, I don't know, social security numbers of the people. So you can use, there are some libraries that you can use to not expose your actual entity out there. The documentation, I didn't like it actually, because this is quite old application. So the documentation is old. It is not that much of the good and shiny look as the other things, but there are very good course of the Kevin Ducks. I really suggest you people go and watch it if you are interested in the OData. That one is really nail up and down of the OData. So I think when you compare it with this slide, this is almost nothing. So I really shared nothing. So here is, and also you will end up with some queries that just really doesn't work, and you don't know why, and you need to figure it out by yourself. So I'm sure now you going to have the question that, okay, my GraphQL also doing almost 30% of this. Why OData? So one of the biggest advantage of the OData, I would say it is modular and distributed code. So already you have the controllers. Each controller can do the different things. But in GraphQL, you will end up with the enormous and gigantic schema. So this schema is not going to be easy to handle. For example, a example of our application, that schema again can be huge because we have a lot of entity, a lot of things. So it's like it is not going to be a happy pass. So it's like with the GraphQL, you need to manage a lot of stuff in one file. Then you're going to have the dynamic query. So GraphQL already supports the dynamic query. There are the different variation, especially the Apollo is supporting this. So it's like you will get almost same things for the data query. So you can query, for example, you can tell I want this field, and it's reflect on your database. Then you have the aggregation. Aggregation is available on the OData, but is not available on the GraphQL. There are the different implementation of the aggregation. For example, Hasura has its own implementation. Apollo has its own implementation. They are not a standard. Each of them has their own variation and their own implementation. So it's like still it is not there. In the .NET Hot Chocolates, they say that they are going to follow Hasura, and they schedule it for the end of 2021. So maybe end of 2021 I'm going to show you another set of presentation that I say why you should use GraphQL. But anyway, this aggregation is like quite a requirement for, at least for me, because just selection that GraphQL give it to you is, it just, to me, is like almost nothing. It's like that overfetching and the overfetching things that the GraphQL is selling is a selling argument, almost is nothing. So in the OData, you are using HTTP verb. In the GraphQL, uglily everything is post, and recently they support get. So you put your request in the get method in the query parameter, but in the Odata you have more verbs. You can see that what is post, what is put. So it's like much more cleaner than what is the GraphQL is providing. Then this one, I don't think you can get it anywhere else. You can out of the box integrate with any other app. It does any big commercial apps, and I don't think you can get it such things with the GraphQL. So GraphQL is still new. It's not like a standard. There are different variation, different implementation. Apollo and Hasura, they have the different implementation. So still it is like a try and error. And one thing that you can do in the GraphQL, you cannot do it in the Odata. You can fetch different non-related resources on single query. So you do once, you send one single request, you get two different entities that is totally not related to each other. So that's you have it in mind that GraphQL from the fetching point is going to be better. But I compare, for example, this integration with other apps, and the aggregation, it is to me is just defeat the purpose of this single query things of that GraphQL. Then one of the things that is that you need to concern is the in the GraphQL you need to tell what every field that you want to get. For example, if you don't tell what you want to get, the result that you are getting is going to be an empty result. You need to tell what field I want. But in the Odata is different. As you see, when you need to, if you can use $select to select some option, and you omit the others. If you don't use $select, it gives you the whole results as it is. So this is a very big difference, because you need to type every field that you need at the front end. For example, your Angular or your React or whatever front end framework that you need to use, every time you need to select what is available there. And this comes with a cost, because the first thing is JavaScript doesn't support reflection. So at the front end, at the execution time, you cannot create any tools that automatically generate this list for you. So all the time you need to go and type it. So if for example you have one entity has 20 fields, you need to type, and you need all these 20 fields. You need to type 20 lines there. You can, or for example, you have on that entity has another entity that has 20, so you need to type 40 lines. So all the time you need to tell exactly what you want to fetch. So this is the from the development perspective quite troublesome. And for example, if you just need you want to remove some fields, you need to go and figure it out where you use and what is used. So it's like it's add a little problem to your thing. So to me also it's like GraphQL is almost lost at this level. And maybe you say that, okay, I am going to type those magic dollar things. No, you don't need to do that. If you are using TypeScript, there is the Odata-query library. You just npm I Odata query, and you just use it give you the function, and you just pass your whatever DTO that you have. You just need to you'll be able to generate your DTO. And there are a lot of applications that generate DTO on top of your Swagger. So from your Swagger, you generate a DTO and just pass the DTO of, for example, the URL that the result that is coming here. After here, for example, you say select. In select, I give you first name and child, and all of these things is TypeScript validate for you, and you will see IntelliSense. And after that, for example, you can filter, and you say, give me any family. I want this field from the family, and I want to find the family that has child, and the marital status. Any of them is recently updated. And after that, when you find these things, expand and make sure that the parents, you also bring the field of the first name and the number of the child of the parents, and also filter anyone that is alive and is not retired, for example. And then, for example, expand and get, for example, their houses, and give me the name of, for example, or the address of their houses. Quite to be frank, just looking at these things is by itself is a very big requirement. So you need, if you wasn't using OData, you need to create a very good, at least SQL query or a new endpoint for that, to give you the list of the name, last name, ID, and the things, and it has child, it is recently updated, and you want to also have the list of the parents' names and childs, and also make sure that those parents are alive and not retired, and you want to get also the list of the houses. So such requirements that it's like abruptly come to you and you want to get these things, you can do that. If you want to do a count, aggregation, you want to get the sum, average, whatever you want to do, it is just JSON level is far away. And to be frank, if you look at it, you have a GraphQL or not, for the front-end developer is not much different. For back-end developer, yeah, maybe it's different, but front-end developer is still using same as the GraphQL, so you don't lose so much. So yeah, so that's I think I conclude my my talk, and I hope sorry, I think I overused my time like 10 minutes, so I just omit the demo, but you can just search OData, and there are tons of different documents that can help you.
All right. Yeah, thank you, Hossein, for the very detailed and comprehensive talk. Yeah, so without further ado, let's proceed to our third speaker, Jing Lee. So Jing is one of our tech leads in MoneyLion. So his topic will be on event-driven architecture. So this talk will introduce EDA to most of you guys, the audience. It will cover what, why, and when we need an EDA, examples of it, and he will provide resources and guidelines to help you all get started. Yep. So Jing the floor is yours.
All right, give me a second. Let me share my slide. Can someone confirm whether you can see my slide? Okay.
Yep. All good.
All right. Great. Wow, it has been late, and I hope you guys have enjoyed the talk so far. So I think it has been an interesting talk. We had discussion about front-end technology. We had discussion about API design. So now I think I'm glad to present the final chapter, final discussion topic on today on something abstract. It's about building a software architecture around events. So just without further ado, let me get started. To quickly introduce myself. So my name is Jing Yong, and some people call me JY. So I'm a lead software engineer at MoneyLion. So my primary responsibility at MoneyLion building and designing software architecture for various complex systems such as payment, loans, etc. So if you are interested to connect with me on social profiles, so social media, I'm active on LinkedIn and Twitter. So yeah, feel free to come reach out to me after the talk. You want to have a chat about anything. So also we're also hiring software engineer. So I think there are a lot of exciting opportunity in MoneyLion. So I think that you have hear more about this opportunity later after my talk from Daniel. So yeah, so today's agenda will be about event-driven architecture. Specifically, I will talk about a few topics. So we first talk about what's event. Obviously, you need to understand what events before understanding how events can use the drive architecture. Once you understand what is the definition of event, then you could see how this event architecture looks like, what components that make up of the event-driven architecture. And next, you'll see why event-driven architecture matters and what the reason we use event-driven architecture, what problem is solving, and how does event-driven architecture solve the problems. So the three parts, you can see I highlighted them. So this will be the main focus for the talk. So if you have enough time, we'll cover the next two topics. I'll just briefly went through some of the tools available for you to build an event architecture. And lastly, I will talk about some relevant topics. This is more just for FYI. So some of the topics, I think, if you understand them, it can help you better design a better architecture that is based on events. So without further ado, let's get started, shall we? So, okay, one last slide before the before the talk. So just want to set the expectation right. So this is the talk I prepared for back engineers. So I know there are front-end people here, but yeah, I mean, for the sake of time, we need to focus on some of the people. For today, the primary focus will be on the backend part of the event architecture. And for this topic, I will try to make it as introductory as fundamental as possible. So we cover a lot of important concepts, which I think you must know before you try out or using event architecture, apply it to your problem. But I don't assume you have any prior experience. So no worries, you have any, this is the first time you heard about event architecture. So again, as just a reminder, we have a breakout session afterwards. So any questions, you can direct it to me during the session. All right, so let's get started. The simple questions, what are events? So I mean, let's do something really fundamental. So I just put up some definition I found online. So I read through this definition. I highlight some of the important characteristics, some of the words that characterize event. So from the website, the definition of the event is a record that represents something that happens. And something happens can also represent change in state. So events are immutable. Event is order, and people can communicate with each other by publishing and subscribing events. So yeah, this is a general understanding of the events. So let's look at some example of what are the typical event you can observe in your system, in your problem. So as you can see here, I have named a few different events. So essentially, these are the events that come from different domains. And you can see here, each event has a very descriptive and meaningful name that represents something that had happened. So on the left, you can see item purchase event, item ship event, item refund event. So I think what is pretty clear what this event represent. From the name of it, you can probably guess this event probably come from some kind of e-commerce system. So on the middle, you can see events such as account open, money deposited, money transacted, money withdrawn. So again, this is another kind of event where you could potentially see from some kind of finance or banking system. And lastly, on the right, you can see some other events like temperature recorded, pulse recorded. So these are the typical events you could possibly see from a healthcare system. So yeah. So beside having a descriptive name, so event can also present change of state, or we can also carry some other additional information about basically we provide the context of the event. So for instance, you can see some example events that I just illustrated in the previous slide, but I expanded it to include some additional information. For instance, you can see account open events. Account open events, then beside the names, I also include some other additional information about this event. For instance, you can see attributes such as account ID, customer ID, account name, or timestamp. So based on this information, it gives an insight on, for instance, what account has been opened, who is the customer who opened the account, what type of account or what the name of the account the customer has opened, and when did the account opening happen. Similarly, you can see money deposited event, money withdrawn event. Here you can see additional attributes that are relevant to this event but not present in the previous mentioned account open event, such as the deposit or withdrawal amount and the final balance amount after the transaction. So yeah. So again, this by naming the event in meaningful ways and introducing attributes that are meaningful, you could present a lot of different things. In this case, you can represent changes to, changes to a saving account, right? So before I dive into like the architecture part, so let's talk about two other characteristics of the events. One characteristic of event is that it is immutable, means when something had happened historically, so it can be changed and modified. So for instance, if I open an account, I cannot deny the fact that I have opened an account. Similarly, when I deposit money or withdraw money, I can deny the fact that this event had occurred. So this is an important characteristic of an event. So events are immutable. So once happened, cannot be changed. And also events are ordered. So oftentimes we will associate event to the timestamp where the event occurs. So from there on, we can see the occurrence of the events in the chronological order. For instance, here you can see that the money deposit event and money withdrawn event have timestamp, two different timestamps where the deposit event come before withdrawal. So again, this holds true for all events. So the events are ordered and you can't change the order. So sometimes why it is important is because you might need to know certain order of the event to handle them accordingly. Yeah. So let's move on. So now that I understand the events, now I will just go through a few definitions of the event-driven architecture where I can find online. Again, each of these definitions are very different, but I also highlight a few keywords. But more importantly is once I highlighted these keywords, I will provide you more illustrative examples to demonstrate why and how event-driven architecture is done. So first of all, from this book software architecture pattern, so mentioned about distributed and asynchronous architecture pattern. And we talk about scalability, we talk about stability. So these are the inherent characteristics of event-driven architecture. So we want to use event architecture when you want to have highly scalable application and highly adaptive application. And how does it achieve this? It's through connecting different highly coupled components, single purpose component, through events where each component can asynchronously receive and process events. So I have still a four more definition to go. So again, so this has been similar to the previous definition, but the key here is event can carry either the state or the identifier. So this is something I have illustrated in the previous slide. So as you can see, some events can simply just identify that in this case, just the name of the event. So this implies this is a notification of some event that occurs. Besides the events identifier, you can also carry state. In this case, the additional attributes. So another definition of event is a model for application design. So and also it handles it's a system which will capture, communicate, process, and persist events, and which is different from the traditional request-driven model. So I think I highlight this traditional request-driven model. This is an important point because I will basically compare this traditional request-driven approach with the event-driven approach to clearly distinguish between the difference between the two and see why event-driven approach is more useful than the request-driven approach in certain circumstances. So this is another definition of the event architecture. So the keyword here is the event broker. So I think in the later slide you could see one of the key differences of the event architecture is that it requires additional components that basically allow the exchange of the messages or events between different components. And lastly, this is the last definition I want to share before we deep dive into the specific examples, illustrations. So the keywords here is essentially the event-driven ecosystem. Again, this is similar to the event broker that we talked about. And also we also highlighted something called a broadcast. So this is one of the patterns where you can see in the event-driven architecture where one system can basically broadcast some kind of messages to multiple recipients. So yeah, so this is the definition of event-driven architecture. So without further ado, let's deep dive into the examples of the event-driven architecture to understand more about it. So yeah, so to make the discussion more understandable, so I will compare the traditional request-driven approach with the event-driven approach. So I believe most of the system nowadays are built with the request-driven architecture. At least the one that I have experienced working with. But so that's why I feel that this is something that most people here have more familiar with. So that's why I will put them together so that we can compare how does it differ. So let's begin with the traditional request-driven model. So let's imagine a scenario where I have two services. Just keep it simple. Obviously, my slide is so small, so I can't put more than the services. But typically, you have different services each of the services handle different responsibility. So here I have 2 instances, just for example. Account services handle all account-related operations, while notifications handle all notification-related application. So in a typical request-response request-driven model, each services we expose APIs, could be REST APIs, could be using Odata, for example. And how this message interact with each other is through request and response. So account services in this case, maybe in this case, account services will handle say basically someone withdrawn money via the account services. And what we want to do is we want to notify the customer about the withdrawal that happened. So in this case, what needs to happen is the account service need to send a notification to send a request to a notification service to inform the notification service to send a notification to the customers. And once the notifications send a message to the customers, then you will return a message or a response to the account service to basically acknowledge that the operation has been completed successfully. So let's compare this with event-driven architecture. So here, I will show you like there are a few components here in this architecture. So as you can see here, now I actually have 4 distinct components in this diagram. So we have publisher, subscribers, we have events, we have message channels. So in the event architecture, you need the additional component called event channel or message channel. Essentially, this is one of the medium where allow the exchange of events or messages between different components. And there are 2 components that will interact with each message channel. They are publishers and subscriber. Publisher responsible for publishing events to the message channel, while subscriber responsible for taking the events from the message channel. As you can see here, the publisher can publish a number of events A, B, C, and D in the order, and subscriber can in turn receive these events A, B, C, D in order that is same as the order where the publisher send the events to the message channel. Right. So let's talk about the first reason why first reason why you want to use event-driven architecture and how event architecture can help to enable a better design. So in this case, the first reason of using event architecture is to make sure that you have a loosely coupled design. A loosely coupled design allows system to be adapt more easily without changing like too many parts of the system. So for instance, now let's send our scenario. Besides informing the customers some events happen to their account, we also need to do something about say in this case we want to have a message service called PFM service. PFM service stands for Personal Financial Management Service. So what we want to do is we want to make use of the customer's transactions behavior, like for example when they make a purchase, when they withdraw money, when they disburse money. Based on that, we want to generate a meaningful and useful financial advices for the customer. So you can see now we are doing 2 things instead of 1 thing. So in the traditional request-driven approaches, what you could do is you need to modify the account service over here to send additional requests to the PFS service. So as you can see, you need to send 2 requests, and then each of them will respond to the account service. So yeah, the first problem you can see here is this will require changes to the service account service. We'll talk more about like what are the problems, but let's see how event architecture can solve this. So event architecture. So I've been talking about the pattern called broadcast. So essentially, what the components, this message broker, message channel component allows you to do is to broadcast events. So in this case, since the account service already published events to this message broker, it's still modifying the account service to send the same message to the new service. What we can do is we can make this event message broker or message channel to broadcast events. So as here, I simply broadcast the event into 2 streams. So one stream will be consumed by the original notification service, and the second service can consume from the new broadcasted streams. So each of these services can consume the events from the stream independently without having changing the account service. So this is one of the good example of why event-driven architecture really shines. So loosely coupled design is something we always hope to aim for when we design a system architecture. So here we only talk about 3 systems. So in typical real world example, you don't deal with just 3 systems. You generally deal with maybe 10 or 1,000 of systems. So imagine you use this request response model. You're not gonna scale easily, and you might end up having a very complex architecture. But with this event-driven architecture, you can simply add a new streams that can be consumed independently without changing this and limiting the changes need to be done to the architecture. So another reason of using event-driven architecture is for tolerance. So same example here, right? So account service, once someone make a transaction, for instance, you need to ask the notification service to send a push notification. You need to ask the PFN service to generate financial advice. So what happens when one of the service doesn't is failing, right? So in this case, you can see the PFN service is not reachable. It can be for many reasons. So this is very common in the distributed system or microservice architecture. So it could be the service is running out of storage, or maybe it's now crashing out of memory, or maybe it could be a network issue, right? The network just not reliable. So in this case, you can see now we have a problem. How could the account service handle the failures elegantly? So in this architecture, oftentimes what you end up to do is you need to have a lot of handling logic at on the requester side or the sender side. Account service, we need to handle a lot more complexity, which might not be necessary. But if then they are not handled properly, you might end up in some kind of inconsistent state. You might have notification being sent, but no new device being generated. So how event-driven architecture can help cope with this? So again, now we can see why this this component of a message channel or event broker really shine. So when one service is down, in this case the PMS service is not available again, what happened here is account service and notification service are still available. So in this case, there's no worry about these 2 services. This service can still be consumed, to still be function in a normal way. But in the event for this service where the PFN service is now, what we could do is we can allow this message broker component to buffer the unconsumed event. So basically, we can keep track of which event has not been consumed by the downstreams and just buffer it over here. So, and why is it important? So because the system doesn't go down forever. So maybe you go down for some time, maybe you deploy something new, maybe there'll be maybe just intermittent network error. So after some time, the system will recover by itself. So once the system recovers, what you could do, you can just basically resume whatever event that has been buffered in the message broker. So in this case, you can see that the fault can be handled very gracefully and very easily without complicating the architecture too much. There's no complicated logic at the account service in this case to handle the field delivery of the messages or events to the downstream services, in this case PFN. So PFN can basically don't worry about the loss of messages because the buffer help retain the message while the system is not available. Okay, more reason for using event structure. Let's look at an example on how architecture will need to deal with scale and resiliency. So as you can see here, we have the same architecture. In this case, you can see these 2 arrows are kind of being enlarged. So I use this to illustrate the increased amount of traffic to a particular service. So in the request-driven architecture, so there's something. What happens here is generally you might have a situation where you the requester, in this case, account service, end up sending too much requests to a downstream service. So in this case, a downstream service have no say on how much requests it can handle. It simply take whatever request being sent to it, right? So what end up happen is the downstream service might end up crash when it hit its limits. So obviously, I mean, there are ways to deal with it in the traditional request-driven architecture. One can simply say, oh, let's scale out these instances, have multiple instances, and we put a load balancer in front of it. But again, sometimes this is the example. We have only 3 services, but in normal circumstances, in the real operation, your service might interact with more downstream services. So you need to also cater for whether the downstream can scale at the same level. So this is an example why you can see the traditional request-driven model might not be as scalable when it comes to there's a surge or spike in the traffic. So let's see how the similar thing can be applied to the event-driven architecture. So this is actually the same. This is actually the same as the previous one. You can still do load horizontal scaling when it comes to event-driven model. So what you just need to do is just spawn more instances of a certain service which you expect more traffic. Then you could have each individual service to subscribe to events and try to distribute the events more uniformly, so that you could basically prioritize the work and scale. Again, this is subject to the same problem, whether your downstream can scale uniformly. So yeah, let's see it. But one notable benefit of event structure is there are other ways to work around this. So besides simply accepting whatever request provided by the requesters or producers or publishers, event-driven architecture support a characteristic known as back pressure, or sometimes people just simply known it as flow control. Essentially, it's a mechanism where it allows the downstream to control the rate of the consumption. So as you can see, there's a different direction between the request models and also the event-driven model. So request-driven model, the upstream, the producer, push the information to the producer. On the other hand, on the event-driven model, the downstream, the event consumer, pull the information from the consumer. So since the action is initiated from the downstream can basically configure the number of events that it could take at a time, then only request for the number of events that it could handle. While there are new events coming in, those events can be buffered at the infrastructure without overwhelming the downstream service. So this is one of the benefits of event architecture. It allows more option for designing highly scalable and resilient architecture without overwhelming the system in architecture. So yeah, I think I almost cover like all the important part of the event architecture. Just to summarize, there's some very quick assessment of event architecture. So event architecture can allow you to build system in a highly agile manner. So you can add new services to remove new services, new services without changing the architecture too drastically due to the slick couple design. And because the system are highly independable, you can also make each of the individual component easy to deploy. So, and of course, obviously you can see that how event architecture can outshine in terms of the performance and scalability. But of course, there are some trade-offs with this event architecture. So obviously, there will be more components need to be added to the system, which can in turn make the system harder to test and maybe make the development cost slightly higher. But again, this is common to make trade-off when you design architecture. So overall, you need to choose event architecture when you favor high performance, high scalability, and highly adaptable system. While for very simple, if you're designing a simple system, maybe a request-driven model is sufficient. All right, just quickly go through the final two sections. So we just want to talk about some of the tools that you could use in building an event-driven architecture. So there are a lot of different tools you can use. So there are tools such as message queues, transaction message queue like RabbitMQ, Active queues, or there are tier 2 provided by the cloud providers such as SCNS, SQS, EventBridge, or even there are more sophisticated tools such as Apache Kafka. So again, each of these tools have different, they work differently and they have different characteristics. So I won't cover like how individual tool works due to the time constraint. But I think it's important to understand this tool and see how this tool can help addressing the concerns in the architecture. So I provide some of the questions which I often ask myself when I'm choosing a tool. And this question effectively helps me to understand how the tool can address certain problems. For instance, one of the problem that you often see is how we make sure that the message are being are durable enough. How to make sure the events are not lost during the exchange between services. So in this case, you need to, so suppose let's take example, like if you're using SQS as a tool, you definitely need to know about things like reject policy, right? So this is some kind of mechanism where allow the message to be delivered in case the message is not processed successfully. So yeah, so these are a few questions where you could ask yourself to understand more about the tools. So not sure whether I have some time. I think I still have some time. Let me just cover the last part of it. So just some relevant topic. I think each of them can be talk of its own. I just want to briefly go through them because I think they are relevant for you to. They might help you in designing your event-driven architecture. So some of them are domain-driven design, event sourcing, and command query response to this situation. So domain-driven architecture is something. This is a technique where you could basically design your system based on the domain's semantics. So basically, what you do is you require you require you to understand your problem statements, identify the events that occurs within the domain boundary context, and understand how each of the events interlink with each other. How one event can trigger another event. So I just want to highlight some of the where you like one of the example technique where you could use. So event modeling is one of it. So event modeling essentially is one of the tools where you basically outlines the events in the control orders, and basically you could use this to design your system topologies, like in the implementation phase later. So another another interesting related concept is called event sourcing. So this is, I highlight this simply because people oftentimes confuse this event sourcing with the event-driven architecture. So event-driven architecture essentially is a technique that allows systems to communicate with each other using events. On the other hand, event sourcing is a mechanism where people can use events as a way to represent the change of state at a persistent layer. So these are interrelated. You can use them. You can use them a lot side by side. But it's important to understand their differences. So event sourcing is about how do you model the events within the system, while event-driven architecture is how do you use events between different parts of the system. So just a very quick example, this is how event sourcing looks like. Essentially what you have is basically you have a new component called event store, where events are used to persisted to the event store to present the state changes. And what you can do is you can basically derive many different states from these events being persisted to the event store. And also what you could do also is, this is how you can see when events sorting can be used in conjunction with event-driven architecture. You can even pipe the direct or depth the event store events to external streams so that it can be consumed by external system application. Last but not least, you can use a pattern called C4S, which is also one of the very commonly used pattern in the event-driven architecture, where you basically allow the change of information between the services, and you allow the right. Basically, you basically design your system into different using a different model. One model that is suitable for write, one model suitable for read, and use events as a means to synchronize the two pattern. So yeah, I think I cover like my topics. So I think that's all from me. Thanks everyone.
All right. Yeah. Thank you, Jing Yong, for again another comprehensive talk. Just as Jing Yong mentioned, later we'll pass the time to Daniel just for a brief introduction about MoneyLion. Just a note: our breakout rooms will start soon. So if you have any questions you want to ask our speakers, keep them in mind. We will start them soon. But before that, Daniel, it's yours.
All right, thanks, Andrew. And also thanks, Jing Yong, for sharing event-driven architecture and bringing in some of the relevant concepts such as CQRS and event sourcing. So in MoneyLion, our engineering team is using event-driven architecture on processing payment. Currently, a lot of our services are in microservices architecture using request response as the main form of communication. But we do see the need for us to gradually move into event-driven architecture. With that, we do need additional engineering capacity in order to get there. So we are hiring. We are hiring a number of back-end engineers and developers. If you're interested to work on microservices and event-driven architecture, please drop me an email. Or if you prefer to go through the proper channel, you can also apply through LinkedIn. I'll be happy to talk to you more. So for now, I'll pass the floor back to Elisha.
Thanks, Daniel. Hey guys, so let's proceed to the photo session now. So feel free to turn on your camera. We would like to see all of your faces. So let's just have a quick one. So total here we have four pages. So that means we have to smile for 4 times. Okay. So let's start with the first page. So okay. So let's wait for some of them to turn on their camera. Okay. So ready, guys? So let's count in 3. Say cheese. 3, 2, 1. Cheese. All right. Oops. Some of them just on their camera. Okay. Let's do it again. Okay. So guys, say cheese. Yes, thank you. Let's proceed to the second page. Right. So 1, 2, 3, say smile. All right. And the last page. Okay, ready? 1, 2, 3. All right, cool. That's it for the photo session. And now let's, I think the breakout rooms are open. Yeah, so what you need to do now is just to, so there are 3 rooms. So the first room would be, you can approach if you, let's say you want to approach the our Ivan, okay, to ask about the topics about the Jamstack, okay, and the second room would be Hossein regarding Odata, and the third room would be you can approach Jing Yong. The topics will be EDA, all right. So what you need to do is actually just to, okay, let me share my screen now. Can everybody see my screen? Yeah, so you will see a join button just next to the speaker's name. Yeah. So yeah, the rooms are open. So you guys can start to join in and interact with our speakers.
I mean, like the client side kind of stuff, like where you are presenting.
Correct. Because if you you have a lot of, you're going to have a lot of clients, and they are going to use through a lot of different endpoints. So for example, you are going to have the web, you're going to have the mobile, or you are going to integrate with some other application that those application doesn't support gRPC. For example, the simplest event ID, but
Yep.
you don't have a running number, right? Or you have a running number there.
So the purpose of having this event ID is just to the purpose of event ID is to uniquely identify an event. It's not really about scalability. So
Okay.
so the idea of event, so I think one
All right. Wow. Okay. Awesome. I think everyone's back. Okay. Yeah. So for those of you who are still here, this marks the end of our first tech talk. So if for those of you who are not, just stay tuned. Like our Facebook page, MoneyLion Malaysia. We'll post future updates, future events there. Yeah. As Daniel put it, feel free to email him if you're looking for career opportunities. We're still hiring and stuff. But yeah, that's the end of our event. We hope that you get what you expected from this. We hope you got the insights you wanted. We hope you learned a lot through this event. I certainly did. So yeah, that's the end. So have a very good night and have a good week ahead. Thank you so much.
Thank you, guys. See you.
Thank you,
Yeah.
guys.
Bye. See you guys.
Hey,
Good
guys.
night.
Bye. See you
Yeah, have a
guys.
good
Bye.
night. Bye-bye.
Thank you. Bye-bye.